Hello class, welcome to Envisions Math Lesson 10-2. So I'm going to be a little upfront with you here, a little honest, not a little honest, a lot honest. Lesson 10-2 can be probably more confusing to most of you than helpful in the way that Envisions shows you how to solve problems, okay? I'm going to try to be a little more helpful than confusing, actually a lot more helpful than confusing, hopefully. What I'm trying to say is the strategy that they show you to solve these problems today with modeling addition and subtraction problems using mixed numbers is a strategy that is a stretch and can be difficult and painful for many. So what I'm going to do today is show you how to add and subtract mixed numbers without worrying about drawing models. Now, if you would like to draw models today using drawing fraction strips, you can look at the assignment today. Feel free if you would like to. But I'm relieving you of your responsibilities of needing to draw models if you would prefer not to. What I'm going to do is show you now a few examples of how you can add and subtract mixed numbers, and I am going to do so without using models. Okay? All right. So, got my handy dandy expo marker and my little handy dandy whiteboard, and we will begin our lesson on adding and subtracting mixed numbers without using models. So the first problem we have here is 1 and 2/3 and 1 and 1/3. Now, when you are adding or subtracting mixed numbers, it's always a good thing to look at the fraction parts first. So in 1 and 2/3 and 1 and 1/3, I have 2/3 plus 1/3. Now, I look at my denominators first, just like I was taught to in the last unit. They are alike. We do not have to worry about finding the least common denominator in this case, so that's nice. Now I need to look at the numerator, 2 and 1. I am just adding the numerator and keeping the denominator the same. 2 plus 1 is 3. So when I add 2/3 plus 1/3, I get 3/3. 3/3. The numerator is the same as the denominator. That means I have all the parts to the whole. So yes, in this instance, when I add 2/3 plus 1/3, I get 3/3, which is equivalent to 1. Okay, so I have added my fractions 2/3 and 1/3, and I've gotten 1. However, we're not done yet with this problem because we also have 1 whole and 1 whole. And since I added the fractions and got 1 whole, I have 1 plus 1 plus 1. And you probably learned how to solve that many years ago, correct? Yes, the answer is 3. So we just added some mixed numbers. 1 and 2/3 plus 1 and 1/3 equals 3. I'll write that down right there. Very nice. For our next problem, we have a little bit added level of difficulty. I'm going to remember again, when you're adding and subtracting mixed numbers, I want you to look at the fraction first. In this case, we have 2/4 and 3/4. Same denominator, so that's nice. Don't have to find the least common denominator. But I look at my numerators, and they are 2 and 3. So if I'm adding 2/4 plus 3/4, I get 5/4. So I'm gonna write that down just so I can remember that. I'm gonna take away this equal sign for a second. I got 5/4 when I added up the fraction. So 5/4, that means I have more than all the parts to the whole, right? 4/4 equals 1 whole. So if I have 4/4 equals 1 whole, then I have 1 more fourth, right? So 5/4 is equivalent to the mixed number of 1, because 4/4, if I take 4 away from this numerator, I have 4/4 that equals 1 whole. If I take 4 away from that numerator, I have 1 more left over, 1 more fourth. So 5/4 is equivalent to 1 and 1/4. Well, I have now added my two fractions. I have gotten the answer of a mixed number, but I still need to remember I have the two other whole numbers here. 2 plus 2, do you guys know what that is? Yeah, you've known for a while. It's 4. It's 4. So we're going to add that onto the answer that we got when we added the two fraction parts. So now I have 1 1/4 plus 4. 1 1/4 plus 4. But there's only one fractional part now. So I'm going to add the two whole numbers, that's 5, and leave the fractional part, that's 1/4. So 1 1/4 plus 4 is 5 1/4. So that was a lot of steps, but the addition that we did was not very difficult, right? Like 2 plus 2 and 4 plus 1 and things like that, right? You can do that. The main thing is what you're doing is you're taking that fraction and turning it back into a mixed number. Okay, so you have to think about all the parts to the whole equal one whole, right? If you have 4/4, that equals one whole, and then you have remaining parts up there, the denominator stays the same, but then you continue on with the fraction. So 5/4 equals 1 1/4. Then we just needed to remember to add the other two whole numbers. All right, our last one is a doozy. So again, I will try to be more helpful than confusing. So again, I ask you to look at the fractional parts first. We have 1/8 and 5/8. And by the way, do you notice we're subtracting this time? That's an important thing to notice too. So 1/8 minus 5/8. Wait a minute. So we have the same denominator. That's good. But 1 minus 5. Now we're not working with negative numbers right now. So I can't have 1 of something and subtract 5 from it. So guess what I need to do? I need to make that numerator bigger than the 5. How in the world can I do that? Well, remember in this problem we talked about, the denominators, all the parts to the whole, right? Well, what we're going to do is we're going to take away, we're going to essentially borrow from this 5. Yeah, we're going to harken back to our days of borrowing, okay? So this 5, right? If I take 1 away, that's equivalent to 8/8, okay? That's one whole is 8/8 because we're dealing with 8 in the denominator place. So if I change, and I'm just going to draw a little arrow here for a second. We're ignoring the 3 and 5/8 for a second, okay? I'm going to take this 5 1/8. I'm going to borrow from the 5, turn the 5 into a 4. But when I borrowed from the 5, I took 8/8. What's 8/8 plus 1/8? 9/8, right? So now I have the mixed number of 4 and 9/8. I just changed 5 and 1/8 to 4 and 9/8 because I need to be able to subtract this number, and I couldn't do it very easily. But because I can't do 1 minus 5, but I borrowed from the 5, I borrowed 8/8 from the 5, turned the 5 into a 4, and 8/8 plus 1/8 equals 9/8. Now I have 4 and 9/8, and I'm still subtracting 3 and 5/8. So let's put that over here. 4 and 9/8 minus 3 and 5/8. This is looking pretty good. It looks like I can solve it now. So let's look at this. I'm going to look at my fractional part first. I have 9/8 minus 5/8. Denominator the same. Good. Numerator, the first one's bigger than the second one. Good. So 9/8 minus 5/8 is 4/8. So am I done? No, because I still need to use our whole numbers. 4 minus 3. What's 4 minus 3? 1, correct. So my answer is 1 and 4/8. Now, before I write that down, 1 and 4/8, I need to remember that I should simplify if possible. Now, 4/8, 4 is half of 8, which means 4/8 is equivalent to the fraction 1/2, okay? So if I'm doing 4 minus 3, which is 1, and 9/8 minus 5/8, which is 4/8, and I have 1 and 4/8, to simplify that problem, I would have 1 and 1/2. So that is my answer. Now, I highly suggest if you had any difficulty following along with my problems today, that what you can do is go back during this video and pause it through each step that I take to solve your own problems. or to understand better what I'm saying, okay? Now, feel free again to look at Lesson 10.2 reteaching. Feel free to look at the Lesson 10.2 video, of course, that we get from Envisions. But again, I am allowing you to solve these problems just by adding and subtracting mixed numbers, and you do not need to use drawn models if you do not want to, okay? I'm starting to trip over my words, so I'm going to stop this video. So anyway, I hope you have a good day, and please let me know if you have any difficulty with Lesson 10.2. Thank you.